So I wanted to show an example of what I've been working on. I have a fan in my 3D printer that is not responding to the motherboard. And you have to do speed control in order to turn down the amount of airflow according to the type of filament you utilize. So this is my solution. There's a lot of different ways you could have done this. You could have got a power supply that is adjustable with a dial and directly to a plug. But I wanted to have something that I could easily reach and change settings if I needed to and adjust it. So this was my solution. So I basically got a tip 120 transistor, a 50K potentiometer, and wired that over to a voltage meter. And then of course I'm doing a test fan. Now I'm going to be putting this on a 24 volt system, but it doesn't matter 12 or 24 volt, it doesn't care. Okay, so here is how we're going to do this. I basically have a power source. It's coming out with positive and negative, in this case 14 volts. I'm going to do a 12 volt fan. Whenever you're using a potentiometer, it's going to knock the voltage down a little bit. So let's explain the theory behind this setup. This is basically like a voltage controller, which is also going to enact the speed control on the fan, because the less voltage you send to the fan, the slower it will go. So how I'm going to do this is I'm going to wire it so that the positive voltage goes to one side of the potentiometer. It then gets jumped off the potentiometer, goes to the center pin of the transistor. Whenever you watch videos on YouTube, they show you the schematic, but they don't really tell you, for the most part, what's happening. So we have voltage coming off of the potentiometer. It's just basically a jumper over to the center pin of the transistor. The pin to the right of the transistor is basically voltage out. The potentiometer is controlling how much voltage is going into the transistor and then coming out of the transistor. The center pin is going to the left side of the transistor. So this is all pretty much the positive side. The negative side is going to one pin of the potentiometer and then straight through to whatever device is going on the end of the line. So I'll do a drawing to show you how this works. All right, so here's a drawing that kind of represents what I did. Now, mine ended up being the potentiometer, positive and negative were reversed, so all I had to do was flip the potentiometer, because the center pin is always the same. It's always going to go to the B of the tip 120. In my case, I used a 120. This one's showing a 122. Same thing. But you're going to have the negative go directly to the fan, and then one side of the negative is going to go to one side of the potentiometer. It's then going to proceed to go to the left pin of your transistor. The center pin is going to take your power on the transistor, and it's going to be on the power out of your potentiometer. If you happen to wire the positive and negative backwards on the potentiometer, that is okay. It will just put more resistance instead of less resistance when you turn it right. And it will not blow it up. You just flip the positive and negative, you should be fine. And then the E is basically your output for whatever you're putting on the end, whether it's a motor or it's a fan. And I'm going to try to get everything into this little box that I 3D printed so that it won't look like crepe. All right, so this is a better angle of it all wired up now. So I've still got my 14 volts. I've got my fan over there. And now I'm going to attempt to try my fan control. So it's got to get at least 3.2 volts to turn on. So I went from this point to that point. And I'll figure out later what percentage my fan is moving opposed to how much voltage. So I'm just on a tip right now being on. It gets brighter when I give it a little bit more voltage. So there's right there, got 6 volts, pretty much where my drill hole is here to keep the potentiometer in place. I'd call that 50% if you're talking 12 volts. And then there's going to be 80%. And as you can see, the air is moving. And 100%. Now I'm going to be doing 24 volts, but I figure it's going to be pretty similar. Alright, so there's my voltage controlled fans controller. I mounted it on the box. Pretty much the head drops down. So this is as high as the head can go. So it's not in the way of any of the other wires. And then these are my wires, and I just stuck them up this one area here. And over to this unit here. That looks like the main fan power coming in. I'm gonna have to back trace everything, figure out where everything's going, and then tie it in. Okay, so I made some progress. The fan wire was connected there. I rerouted it, tied it into a connector, ran over to here, tied that into the output of my power. Now this is all temporary, so I just soldered and taped really quickly. I then am taking the input of my panel and routing it over to that hole on the speed racer. So once I figure out how to get power up to there, I'm just going to plug it in. I made it modular, and we're going to test it. So you turn it on. You can kind of hear, but that's low for the fans. Okay, 9 volts. And now you can kind of hear the fan. 12 volts, 13 volts. Fan's a little louder. 17 volts. Fan's pretty much kicking as high as I can go. I didn't have a 24 volt power supply, but since I made it modular, I just changed the power supply. I changed the high range of the output. But since this thing was blowing too hard anyway, 17 volts should suffice for now. It's almost 18. And then if I get a 24 volt power supply, I just wire it in, just plug it in, done. And if I get the new motherboard, I take it out. Although I kind of like it, it's kind of cool looking. So anyway guys, that's my video. Hopefully you found it informational. If you did, please click like, and if you really liked it, please subscribe. This was a cheap solution, but a crude solution, but a temporary solution also. So hopefully this will help you in your future projects. That's my video. Thanks for watching. I'm gonna get the tech out of here. Later.
Holding on to memories that we've shared. My evidence you once really cared. I'm reaching for a hand to pull me up. One open to an everlasting love.